So, ladies and gentlemen, you are all welcome to my YouTube channel. So today we are going to look at how we are going to solve problem of Handerson-Hasselbalch equation. So in this case, we are going to start with this question, and the question says find the pH of a solution with pyruvic acid and sodium pyruvate. Given that the concentration of pyruvic acid was 0.05 and the concentration of sodium pyruvate was 0.6, and of course the pKa is given as 0.5. So now let's start with the data. So of course from here we have the pH. So the pH is actually is unknown, and then we have the concentration of pyruvic acids. Concentration of pyruvic acids will be equals to, so we have concentration of pyruvic acids is equal to 0.05. We have 0.05 molar. We have 0.05 molar, and then the concentration of sodium pyruvate, is given as, we have the concentration of sodium pyruvate, and it is given as 0.06 molar. And of course for the pKa, it is also given as, for the pKa is also given as 4.5. So from here we can just actually check the equation, and then we calculate our pH. So how do we get the equation? And of course, to get the equation is simple. We use the Handerson-Hasselbalch equation, because we have pKa and we have concentration of our conjugate acid, and we have the concentration of our acid, and then we also have the concentration of our conjugate base. So therefore we are now going to use the formula that says pH is equal to, we have the formula that says pH is equal to pKa plus log of conjugates, we have log of conjugates base divided by the weak acids, and this formula is called Handerson-Hasselbalch equation. So of course the pH already given, and the pKa is already also given as 4.5, and then the conjugate base from the question here, the conjugate base of course is the conjugate base here is sodium pyruvate, and of course our acid is this pyruvic acid. So it's simple, we can just substitute and then get the pH. So now how are we going to do that? Then we are just going to say, now we have our pH is now equals to, it's now going to be equals to 4.5 plus log of open brackets. Of course we have conjugate base as 0.6, so we have 0.6 divided by 0.5. So now we have pH is equal to 4.5 plus log 0.6 divided by 0.05. Yeah, it's 0.05. So now how are we going to do it? Then it's simple. We are now going to continue with the pH, then so how are we going to get it now? So we are now going to get log 0.5 divided by, sorry, log 0.6 divided by 0.5. So therefore, we are now going to say pH is equal to 4.5 plus log of course, if we now take 0.6 divided by 0.05, it is going to give us 12. So now it's simple. We can now just say log 12. If we now take the logarithm of 12, what are we going to get? So log 12 is going to give us 1.079. It's going to give us 1.079. So therefore now pH is equal to 4.5 plus 1.07. So therefore at the end, we now have 1.07 plus 4.5. So we have 5.57. So our pH now is equal to 5.57, and that is the answer. So, and of course, then we are now going to look at another question. We are now going to look at another question. So, of course, then in the next question, we are going to also, so you see, in this case, we are going to find the concentration of hydrogen ions in an acetic acid solution, given that the pKa was 4.76 and the ratio of the concentration of acetate and acetic acid is 0.6. And I think this one is also simple. And how are we going to get this? We are now going to say, of course, we are going to apply the same formula, that is Handerson and Hasselbalch equation. So pH is equal to pKa plus log of course, in bracket we have our conjugate, we have conjugate base, we have our conjugate base divided by the weak acid, and of course the concentration of the acetate and the acetic acid is giving us 0.6. So what does that mean? It means that if we now take the whole of this, that is the whole of this, the ratio, the whole of this, that is conjugate base and acid, is 0.6, because you see it is the ratio. So the ratio of the concentration of acetate and acetic acid is 0.6. So it means that everything here is 0.6. It's 0.6. And of course, the pKa here is already given as 4.76. So therefore, we are now going to say that our pH is equal to 4.76 plus log 0.6. So now we have log 0.6 is going to give us minus 0.221. Minus 0.221. Sorry. So therefore now we have pH is equal to 4.76. So log 0.6 is minus 0.2221. 2. So now we are now going to get the final value of the pH. So therefore the pH now is going to be 4.55. It's now going to be 4.55. So now from here, the question says we are to get, or we are to calculate the hydrogen ion concentration. So therefore, we know that from the pH, we can easily get hydrogen ion concentration. Since we know that pH, since we all know that pH, we know that pH is equal to minus log of hydrogen ion concentration. Hydrogen ion concentration. So to get hydrogen ion concentration, we are now going to use this 10 power minus pH. So already we know our pH now. So we are now going to have 10 power minus 4.55. So now, if we now press our calculator, we are now going to have, so therefore, since we know that hydrogen ion concentration is equal to 10 raised to the power of minus pH, so we have our pH as 4.5. So we are now going to say 10 raised to the power of 4.55. And then finally, we have 4.82 times 10 raised to the power of minus 5 as our pH. So thank you for watching my video. And if this is the first time you are coming to my channel, please subscribe.